correspondence group within IOLA looked at this problem, the relevant systems and standards were found to already exist. And IOLA Guideline 1072, which, as I said, was approved at the end of last year, identifies these standards and advises on implementation. So it's not setting up a new standard, it's really collecting together what already exists. One essential point is that aids to navigation authorities need to communicate information to hydrographic authorities, and appropriate data transfer standards have been developed already for the use with ENC data, the present one being IHOS 57 and in future the S100 series. So data representation should conform with the IHO special publication S57 in the short term, by which we mean the next 5 years or so. And symbology should be in accordance with the relevant IMO Safety and Navigation Circular 243. In the medium to long term, that's beyond 2015, formats should align with S100. And I'm saying align with, I'm not saying that they should be necessarily exactly the same as. IOLA could, if it considered this appropriate, establish a data registry through the International Hydrographic Bureau. Applications should follow the OpenGIS architecture, and features should be, in relational databases, should comply with the relevant ISO standards for those, and use spatial and temporal schemas defined in ISO 19115, geographic information. A markup language defined by SGML for exchange of data between administrations, suppliers and users would be appropriate. The correspondence group which I mentioned looked at examples of systems already either developed or in hand. The Australian one, which was discussed yesterday, was one obvious example. There was also a UK Hydrographic Office software which was used for compiling information on aids to navigation, among other things. The GLA had demonstrated XML schema for aids to navigation, and IOLA was in the process of adopting this for the DGNSS on its own website. The Portuguese system, which was discussed in a paper yesterday, a web-based system for providing MSI, was clearly a good example. And there was also development work going on in the US, supported by the US Coast Guard. So all these examples were looked at and common features identified in drawing up the guidelines. This example is the one I mentioned, produced by the GLA some time ago, and this one is an example of data on the right from XML on a DGPS station, and in this case on a buoy. So that's how you can, that's one way of presenting it. The benefits of harmonizing the approach are coordinated management of aids to navigation information in a digital environment. And this will allow sharing of information with mariners in real time or near real time, between shore-based operators and with hydrographic authorities for inclusion in official navigational products, and also with equipment manufacturers for inclusion in electronic chart systems, and in the case of DGPS for inclusion in the firmware of the receivers. So that was the current situation, including the IOLA guideline on how to approach this problem. I now just wanted to throw out some ideas about the future. And that's where I see the title, Intelligent Information Systems, coming in. More information for navigation is likely to become available online, and continuous internet access is likely to increase. So that's the context. will be possible to obtain relevant information, I emphasize the word relevant, more rapidly and reliably using intelligent search techniques. Maritime administrations can improve efficiency by providing information in the appropriate formats. And semantic web solutions, where the content description is included in the database, will allow automated information collection and processing. Classes and attributes will allow identification of relevant information, and this can be compared with object-oriented programming. And the Unified Modeling Language uses this approach, and this has been employed in the development by IALA of the initial technical architecture for e-navigation and the Universal Maritime Data Model, which Jan Hendrik discussed yesterday. Looking further ahead, neural networks can learn or be trained to search for required answers more quickly. And dedicated software agents can acquire information with particular relevance, for example, to the location or to the class of the vessel. However, and this is an important note of caution, there is a need to ensure the integrity of information and the system security. This becomes even more important when the data sources are accessed by machine rather than by a human being. I picked up a few interesting examples which I thought I would throw in at the end here. They've all come from a recent edition of the Royal Institute of Navigation's Navigation News. The first one is an aviation application produced by the UK National Air Traffic Services Agency and a company called Airbox, which provides a simple, affordable airspace alerting and positional awareness device that can be regularly updated. Airspace database is three-dimensional, aircraft position and altitude. This just receives alerts, and it's relevant to the current altitude, that's the selection. And it will identify navigational hazards such as aerials, obviously more relevant to aircraft than ships, but one could draw an analogy with isolated dangers at sea and give it a third dimension. The second example I saw was a Google on augmented reality, and this talked about geospatial data with added labelling, i.e. giving it some added context. Geography becomes a filter to remove information that's not important, so you don't get information about other places hundreds of miles away. Some of these applications have the ability to match portions of an image against a database of images, so to eliminate ambiguity. And you can interact with geospatial data on the move. And the last example is very relevant to our sector. And this is a new product from the UKHO, the Admiralty eNavigator. This provides an integrated digital catalogue, product viewer and passage planner. It organises, maintains and displays the data for ship and shore-based teams to provide instant access to all the navigational information whenever and wherever they need it. It's almost a set of instructions for e-navigation. So there is a move from protective to proactive navigation, taking advantage of available conditions. So maybe that's the way we should be looking. I'd like to acknowledge the inputs from ANSA in particular on the producing the draft guidelines which I mentioned earlier, and also the valuable advice we've had recently from the director of the IHO on the application of the IHO S57 and S100. And you'll get more information from me on that address, and I'd be happy to answer questions in the question session. Thank you, Chairman.
Very good. We have quite a few minutes available to us before lunch is ready, so I'd like to open up the floor to any questions that anyone may have. Microphone, please.
Thank you very much. Peter Barton, Netherlands Ministry of Transport. I have one question for